Hey everyone, today we're going to talk about finding probabilities with normal distributions. So the difference between today and what we did the first day is we're not looking at percentages, but actually probabilities. So the first thing I want to remind you of is that when we are talking about probability of something is between 0 and 1 inclusive. If the probability of something happening is nothing, then it's 0. If the probability of something happens is certain every single time, then the probability would be 1, and it could be anything in between. So our answers here are going to be decimals, and we're going to round all decimals to 4 places, okay? All right, so because we're dealing with probabilities, instead of writing my percents in here under the normal curve, I'm going to write the probabilities. So I'm going to use the decimals. So instead of 34%, I'm going to write 0.34, 0.135, right? All we're doing is moving the decimal 2 places to the left, 0015, okay? I know this is teeny tiny here, 0.34, 0.135, 0.0235, and 0.0015. Now, I mean, quite frankly, you could write the percents in there. It's just when you answer the questions, you'd want to make sure you remember probability is a decimal, okay? So let's say that I want to find the probability when x is less than or equal to 12. If you look at our distribution curve here, 12 is actually a nice number. It's a perfect standard deviation away. When that happens, you're going to use the empirical rule. You're not going to grab the calculator, okay? So use the empirical rule since it's on a perfect standard deviation. So if we look at that, when p is less than or equal to 12, you can add up all those probabilities along the way there, and we are going to get, right, 0.84. So I'm not rounding here because that's what I'm going to get, right, the 0.84. Now, if you want to use your calculator to do this, we're not going to, again, use it for that one, but I'm going to give you an example where it's not going to work out so nice here. The probability that x is less than or equal to, it can be any number that's not a perfect standard deviation. I'm just going to use 8.9, okay? So when we're ready to use our calculator, it's pretty straightforward. You're going to jot down for yourself here any notes you need. I might write a couple things, but this is really, the section is for you. But the first thing I am going to tell you is you're going to go to the distributions menu. Okay, so we're going to arrow down here. There's distributions. We're going to go in. And if you notice, there's a whole bunch of choices here. Hopefully you realize that we want the normal, right? Distribution. Arrow down there, arrow to the right. And here we are, okay? So the first thing you always have to type in when you're working with this is what is the mean and what is the standard deviation for the problem you're working on. Right now, our mean is 10 and our standard deviation is 2. So I'm going to do 10. Standard deviation is 2. Go down to next. And now we're in this menu, okay? Now, once you're here, right now I'm asking you, if I give you, the probability of x is whatever, I'm looking for that area, okay, or that probability. If you notice on the left, you see the shading is to the left. That's because it's less than or equal to. If you hit OK there, you have some more options. If you're looking for the probability to be between two numbers, you're going to pick the one with the shading in the middle. And just to show you what happens, it pops open 2 places for you to type in your numbers. Likewise, if you want it to be greater than or equal to, you go down to the last one. You see how it changed your inequality, okay? So we want to go back in, though, because we want it to be less than or equal to. And in that box now, just arrow to the right, type in the value that you want. We're looking for when it's less than or equal to 8.9, and there it is. So our probability here, again, we're going to go 4 decimal places, 0.2914. Okay, and the reason we like 4 decimal places is, well, it's a little more accurate. But if I did want to talk about percentages, it would be 29.14%. Okay, so 4 decimals, and then if it's probability, you write out all 4. If it's a percent, you still use all 4, but you turn it into a percent. That's all you have to do, okay? If you're asked the question, what is the probability that? Here's where we go, okay? Now, the reverse can happen where I'm going to give you the probability, which means I'm giving you the area, and then you're going to find either the x value or the z-score that goes with it. We're literally going to be in the same menu. And let's take a look at this same problem, but I'm going to give you, I'm going to draw a picture here. I'm going to say that if this is our curve, I'm going to find either the z-score or the x value that goes where the area, okay, here, is 0.6134. So you can find the x value that goes with it. You can also find the z-score, okay? Let's find the x value first because we're already set up. Our mean is 10, our standard deviation is 2. Look at your picture, make sure your shading is on the correct side. And instead of typing in where x is less than or equal to, we're going to scoot over again, and we're just going to type in the actual area, 0.6134, hit enter, and we're good. So when the area is 0.6134, your x value is 10.5764. We're still going to go to 4 decimal places unless I say something else. Now, to find the z-score, you have to remember to change your mean and standard deviation. So to go back and do that, you can't arrow up to like click on where you see it on the screen. You have to use the back arrow and you just type it in here. So our mean for z-scores is always 0. Standard deviation for z-scores is always 1. Go down to next. Okay, and now again, we're gonna type in that area again. So scoot over, 0.6134. Hit OK, and there's your z-score, 0.2882, okay? Most common errors are typing the area in where the x is or vice versa. So just make sure that you're in the right position and that you have the right part of the graph being shaded. But that's all there is to it. The calculator makes this so simple, okay? So let's try some problems. And a lot of times we're going to ask you to show some work. So it says assume x has a normal distribution with the specified mean and standard deviation. Find the indicated probabilities. Sketch. So you can make your sketch first, or you can wait till your calculator does it. Your calculator always does a sketch also. So let's set this up. I'm going to go back to set up my mean as 5 and my standard deviation as 2. Go down to next. And I want the probability to be between 2 values. So I'm going to scoot all the way over. And I'm going to go to the middle one, and I'm going to type in my 2 values. So just scoot to the right. We're between 2 and 4. And there we go. And there's the sketch. So when I say sketch, well, let's write the answer first. So our answer here is going to be 0.2417. And then our sketch, I don't need anything crazy here. Okay, so here's your curve. What would be nice to have is your mean. Okay, so we're going to show where the mean is, and then we want it to be between 2 and 4. So it's somewhere in here. Okay, just so that we're looking at, that you have an idea as to where the values are. You know, you could put the 2 and the 4 here, but really the big thing is I want that mean so that I know it's either to the left or to the right. Okay, that's it. Number 2, why don't you pause the video quick and try it yourself? And then come on back. All right, so hopefully you're going to get the right answer here. I'm going to scoot back. I'm going to go back again because I have to change. My mean is 5.2 and my standard deviation is 1.8. I'm going to hit OK. And this time I want it to be less than, so I'm going to go back over here, pick the first one, and we want it to be less than or equal to 7. Oops, not 77. There we are. Okay, so our probability is 0.8413. Again, here's our sketch. Here's our normal curve. Oof. Here's our 5 for the mean. And again, or 5.2 rather. we're looking at when it's less than or equal to 7. So 7 is somewhere over here, and we want all of this area. Okay, it should make sense that it's bigger than a half because it's bigger than the mean, right? In other words, that endpoint is larger than the mean. All right, the last one in this section, again, we have to change our mean is 30, standard deviation is 5, and we want it to be greater than or equal to. So again, I'm going to scoot to the left. I'm going to pick the greater than or equal to shading, and we're looking for when it's greater than or equal to 26. And there we are. So our answer, 0.7881. Here's my sketch. Right, so our mean is 30. And remember, we wanted it to be greater than or equal to 26. So 26 is less than 30. And the shading is this side. Again, it should make sense if you're going over more than half of the graph that your probability is more than half. Okay? All right. The next two here are asking you to find the z-scores, or use the z-scores rather, to find the probabilities. Z-score, automatically we have to go back here. Our mean is 0, our standard deviation is 1. And we want, what is the probability when z is greater than or equal to? So I'm going to scoot over and change to be greater than or equal to. Now your calculator doesn't know that you're doing a z-score, so it's going to still say x for you, but we know it's our z-score because of our mean and standard deviation. So it's 2.1. That's what we're looking for, greater than that. And it is itty bitty, right? So our answer, 0.0179, and our sketch, right, our mean is 0, and we want it greater than 2.1, right? It's all the way over here. It's just a little itty bitty piece, okay? And that's it. One more in this section, so we're going to take a look. We're going to scoot back. It's still the same mean and standard deviation, so I'm just going to adjust here. I'm going to make it in between two values, and the two values are negative 1.2 and 1.8, and there we have it. So we've got 0.849. I'm going to put the 0 on the end so that we're making sure that we looked at all the decimal points there. Here is our sketch. Here's our mean. And it's between negative 1.2, so something to the left, and 1.8. So it's going to cover this middle area. Okay? Pretty easy. I hope you're feeling comfortable. Okay, 6, 7, and 8. Now we have the area, and what you have to pay attention to is what we're looking for. We want the value of z. We want the z-score. So what's nice about that is we're already set up for it. Again, our mean is 0, our standard deviation is 1. You can see that on the calculator. So all I have to do now is I have to look at the graph, and I see that the shading is left. So it's going to be less than. So you have to go back here, grab your shading, and make sure you pick the shading to the left. And then you can type in your area, 0.0630. Okay, so it should look like the picture, right? And we can see our z-score. So our z-score is negative 1.5301. Rounding is going to be key here, guys. I know we joke around about the rounding. Okay, the one in the middle. Now we're looking for a greater than. The shading is to the right, so we're going to go over here. We're going to pick the shading to the right. So we have greater than or equal to our area. Don't forget, scoot all the way over to area, 0.2981. And there we go. Our z-score is 0.525299. Done. And then the last is where we're having this range of values. So again, I'm going to scoot back, pick the middle, and our area is 0.5035, and it's going to give you the two values here. Okay, now it's saying to give you the z-score here, or to find z. So we're just going to give the positive value of z. The negative value is the same, right? Because it literally says find the value of z. So z is positive 0.6800. Okay? All right, next problem. So let's put this into action here. So the students can take the ACT, right, for college entrance. This is going back quite a ways here, but from 2000 to 2007, the mean score was a 20, and the standard deviation is 4. So normally distributed, our mean is 20, standard deviation is 4. Robert got a 27. Find his rank. So rank is a percentile, which we can get from the probability, okay? So what we're going to find is we want to find the probability when x is less than or equal to 27, because what's happening is 27 is like the end, it's the highest part of what we're looking for, and that's going to give us that ranking. Okay, so you'll see what happens as we are taking a look here. In other words, I'm just going to make a quick sketch here. So if our mean is 20 and we want to know what's going on here with the 27, we want to know what's happening here. What number, or I should say, what's the area that's going to give us 27? And think about it, it's a percentile, right? He's over that mean, so he's going to be obviously higher than that 50th percentile. That's what we want. So the first thing we need to do is go back and change our information. Our mean is 20, our standard deviation is 4, and we want to have, again, p is less than or equal to 27. So the p, or the probability, is 0.9599. Because we're looking for what his rank is, we're going to turn this into a percent, 95.99%. And then a rank is like, think about this, when you have standardized tests, they'll say things like, you're in the 95th percentile. They don't usually do the decimals, so we are going to round this to the whole percentile. This is going to go to the 96th percentile. That is his rank. Okay, so this is the answer. So if you're looking for a percentile or a rank, it's the same thing. That grade that they get is the upper boundary, okay? And then you find the probability, turn it into your percent, which we then round to the percentile, okay? Let's try Jill here. So Jill has an 18. We're going to find her rank. Now think about this. The mean is 20. Her rank, if she got an 18, is less than halfway. So her percentile should be less than 50. So let's check that out. So we want our shading still to be on the left. It's the same problem, it's the same standard deviation and mean. We're going to type in her score of 18. Okay. So at the top is her score, the 18 there. So her, again, we're looking at this when x is less than or equal to 18. The probability that that will happen is 0.3085. This turns into 30.85%, which means she is in the 31st percentile. That is her rank. Okay? And then the last question here, what is the probability that a student will get a 25 or less? So it's telling you less than or equal to 25, and this is specifically saying probability. So all we have to do now is type in our 25, and this answer is a decimal, right? 0.8944. And that's it. It's not asking for a rank. It's not asking for anything else. It's asking for the probability. So again, reading very carefully. When they ask for a rank, it's a percentile. Probability, it's a decimal. Okay? All right, just a little bit left here, and then we'll be done with our notes. So now we're going to have here for the SAT, right? We have a mean of 500 with a standard deviation of 100. So before I forget, I'm going to scoot back and change my values. So again, it's normally distributed with a mean of 500 and a standard deviation of 100. I'm going to pop in 500 for the mean, 100 for your standard deviation. Lee got a 470, find his rank. So again, it's the same thing, we just have different numbers. So we're looking for x when x is less than or equal to 470. I'm going to type in my 470, okay? And again, if you look at the graph or you think about the fact that the mean was 500, he's under 500. His rank has to be under 50. So our decimal or our probability is 0.3821, which turns into 38.21%, which turns into the 38th percentile. Arlene got a 640. Find her rank. X is less than or equal to 640. This is above the mean, right? So we should get something bigger than 50. All I have to do is change my number. So we're doing 640. I don't know where that came from. 640. All right. So our probability, 0.9192, which goes to 91.92%, which goes to the 92nd percentile. Done. What is the probability that a student will get a 560 or less? Again, less than or equal to 560. Everything is the same here in terms of the shading and whatnot. Probability, 0.7257. Done. Okay. From questions 9 and 10, which student performed the best? Which one performed the worst? Explain. So the nice thing about percentiles is it's hard to compare, right? Like the SAT to the ACT just based on scores because, it's hard to figure out what's what. But the percentiles are ranking you, right? So it says here again from question 9, let's see who did better. Oop. It's on the bottom here, sorry. So question 9, well, Robert definitely did better because he got in the 96th percentile and Jill only got in the 31st percentile, right? So Robert did better. He had a higher ranking. You have to give some kind of a reason, right? And then in question number 10, Arlene definitely did better here. She did better. She had a higher ranking. And again, you can be much more specific. Her ranking was 92nd percentile and Lee's ranking was 38th percentile. But, we can see the work there. All right, the last bit here, almost we're getting closer to the end. So questions 12 to 14, we're going to find Z. Now for these, again, we're finding Z. So for all of these, again, our mean, I'm going to go back right now. Our mean is 0. Standard deviation is 1. So it's asking you to find the Z value and to sketch the graph. So find Z such that 6% of the standard normal curve lies to the left of Z. So they're giving it to you as a percent. We have to plug in the area. So 6%, move the decimal 2 places. This means the area is 0.06 and it lies to the left. So it's going to be less than or equal to, we're using the shading to the left. Again, we are given the area, so you're scooting all the way to the right and we're typing in the area of 0.06 rather. Again, here we are. This is the area. So that's really all you have to do here. This is the Z. I'm going to just write what our area is here. But our Z score here is negative 1.5548. Okay, that's it. The calculator really is lovely. Okay, almost done. Number 13. So for 13, we want to find Z so that 95% of the curve lies to the right. So again, if we're doing 95%, our area, oops, I can't spell here, our area is 0.95, but it wants it to be to the right of Z. So now I'm going to scoot over and I want to make sure the shading is going to be on the right side, but I want my area to be 0.95. So this is going to be pretty far to the left, right? Because you have almost the whole thing. So here is our marker. Here's the area. This area is 0.95, and that's the z that we want. And we can see that our z is negative 1.6449. Okay. Now we're going to look at one in between, right? So find z so that 98% is going to be between the two the z values. So again, this means that our area is 0.98, and we want it in between. So scoot over, change this to the in between, and we're going to make our area over here 0.98. Again, this is going to be almost the whole graph, 98%. So there's just a little bit left over there, a little bit left over there, but all of this area here, so 0.98. Here's negative z, here's positive z. It's just asking for z. So the z value is 2.3263. Okay? All right, the last question. All right, we have this adult intelligence test scale. On the subtest, the raw scores have a mean of 35 and a standard deviation of 6. Assume these raw scores form a normal distribution. Okay, so right away, boom, going back, I'm going to change my mean. I'm going to change my standard deviation. Okay, what number represents the 65th percentile? So I have in parentheses here, this is going to explain this a little bit more, right? What number separates the lower 65% of the distribution? So I'm just going to make a little sketch over here so you can see what it looks like before we go in. What number represents the 65th percentile? So this is the boundary for all of this, and we want that area to be 0.65, okay? So I'm going to go in, I'm going to type in, I want it to the left, and I'm going to type in my area, 0.65, and there it is, okay? So my answer here, our x value is 37.3119. So that would be someone's rank, right? That's 65th percentile. What number represents the 90th percentile? So 90th percentile, wow, that's like way over. That's the boundary. This area is 0.9, so I can stay right where I am, but change my area. And now the score they would get on this test would be 42.6893. All right, so that's it. Most common mistakes are typing things incorrectly in the calculator, especially forgetting to go back and change your mean and standard deviation. So make sure you always check that. Please see me for any extra help you may need, and now you can just get to your homework. Bye, guys.